Thank you, ICT Academy, for the invite. It's a great venue to be at. I like Central Bangalore. It's easy to come from all over. My name is Viju. I represent MathWorks. How many of you have heard of MATLAB? How many of you have used Simulink? Okay, quite a few of you. I represent MathWorks. We develop MATLAB and Simulink and around 120 toolboxes. In the next 18 to 20 minutes, I'll be talking to you about how MathWorks is involved, at a worldwide level in preparing students for impactful careers in the industry. Yeah, and I represent the education team at MathWorks. The education team at MathWorks is dedicated towards education. We are around 15 engineers and scientists with masters and PhDs. Yeah, it's not a CSR initiative. It's not an extracurricular activity, but it is something that we do as a job day in and day out. We are spread across Bangalore, Pune, Hyderabad, Chennai, Delhi, Kolkata, 15 engineers. So anytime you'd like to talk to us, please do reach out. I know there are a few institutes that we already interact with. There are quite a few of us in the audience as well, and we are happy to talk to you on this. Yeah. So the title of my presentation is Preparing Students for Impactful Careers in the Industry. So I know this audience group has a lot of people. So as an engineering educator, there are many things that you actually take into consideration. Yeah. So the first thing that you might end up looking at as a student, the student might say, I want to build exciting systems and land a job. Or your board of studies might say, are we utilizing our curriculum model fine? Are we building it fine? Or the placement cell or the corporate relationship cell would say, are we collaborating enough with the industry? Yeah. On the other hand, the dean or the head of the department might say, hey, have we transitioned to digital learning? Because we all know that our students, what is the attention span of the COVID batch students now? 90 seconds maximum. They look at the phone otherwise, yeah? So are we leveraging that, or have we gone back to the pre-COVID mode, right? Or research groups. A lot of you carry out active research. Are we actually generating good quality research proposals and funding? And industry, of course. Like for me, the main thing is, do I have strong engineers who I can take into my company? Yeah? And one thing for everyone is, are we continuously adapting to industry mega trends? There are many, many mega trends. We'll touch upon a few a little later in the presentation. But these are some things that you think about. Do you agree? Disagree? Agree? Everyone agrees? Good. Now, the key thing that we're going to be talking about is my presentation is structured into 3 parts: curriculum, collaboration, and the digitalization. And at least one part of it will resonate with you guys. Yeah? So before that, we'll talk about the 4 personas that are a part of the education ecosystem. The leadership, which could include vice chancellors, heads of departments, deans, provosts, etc. So they think of academic excellence and how do they position institutes, what is the ranking, yeah? The faculty, next think about how can I secure funding for research, how do I teach better, etc. For students, it's about the job market is evolving, how can I learn transferable skills? And for the industry, the main thing is we want students with both technical and professional, including soft skills, yeah? So all of these are entities in one. For some reason, this doesn't seem to work. All of these are entities who need to interact with one another. And I think the common thing that's going to come here is the curricula, the collaboration, and the digitalization. So all of these are going to have an interplay among each other. Yeah? Now, let's talk on the curriculum bit. Yeah? So a lot of you might say, hey, VTU decides my curriculum, I don't want it, or the model curriculum that AICTE has provided is too much for my students to digest. It's okay, there are easier ways to do it, which is what I'm going to be showing you here. Yeah? How many of you tried changing the curriculum for a course or introduced any new example in the course you're teaching? Anyone? Okay. And how many of you feel that you do not have time because there's so much admin duty? Or you all have the time to change? Or is it more admin duty? More admin duty, right? There's so much of admin duty that's there, so which is where we are here to help you. Yeah? From a curricula perspective, so how many of you believe this? engineering systems or engineered systems are multi-domain, curricula should be as well. How many of you believe in this? Because 30 years back, when Tata Motors would hire mechanical engineers for car building, they only wanted mechanical engineers who knew how the engine worked, the internal combustion engine, how did the chassis work, how did the brake modeling work and everything. Is that correct? Yeah? But now, when Tata Motors hires engineers, what is the main thing? You see a pretty nice blue color vehicle, that's Tata Motors. What is it? There's some very new Tata Motors vehicle. What is it called? You've seen the Tiago EV? Yeah? So they will, take into account the electrical engineers who know battery modeling, the battery management system, etc. So curricula should be as well. A mechanical engineer might learn about thermal engineering. An electrical engineer might learn about power electronic control design. A computer science person may actually build the software that's on the vehicle. So we need to ensure that the curriculum is interdisciplinary too, not just the end product, but we need to ensure that the curricula is multi-domain as well. So let's take one example, renewable energy. Yeah? Renewable energy means you have windmills. So one thing is you may need to model the physical appearance of a windmill. You may need to look at the mathematical equations that go behind. So you have something called Simscape, something called Simulink, and perhaps you may end up having the physical model that's built on what is called Simscape, or you could build it using ANSYS, you could build it using SolidWorks, any of those. So there are mechanical parts which are used for an electrical application, and of course it's also an environmental problem which is around global warming. We are tapping into sustainable modes of energy, right? Now, very similarly, you have many other cases, but we want to show you that you do have, because these students have the attention span of 90 seconds, we have what is called MATLAB Academy. Yeah? We have various on-ramps. I'm going to be listing a few here. So we do have deep learning, computer vision, machine learning, signal processing, circuit simulation, power electronics. Each of these are 2 hours of video and self-paced hands-on exercises which run on the browser. Go take a look at them. There are around 20 on-ramps that are there. And most of these end up becoming a part of the curriculum in many cases. We have an image processing professor who would say, hey, I want to give the image processing on-ramp as one of the examples. Yeah? We had collaborated with ICT Academy Learnathon, launching a Learnathon in 2020 and 2021. 2020 was on machine learning, 2021 was on deep learning and computer vision. We had around 25,000 completions. Yeah? And currently we are partnered with AICTE on a virtual internship. Roughly 10,000 students are taking these courses with a machine learning and a deep learning flavor. Yeah? So it's very impressive how this self-paced online learning mode has actually appealed to the students. Yeah? The next bit that we want to say is there's an entire set of tool chain. We have around 120 toolboxes starting with basic MATLAB and Simulink, which are our flagship products. Optimization. Any math faculty in the audience? Mathematics? No mathematics? Okay. Simscape, image processing, and then object-oriented programming. Yeah? The next bit that I want to talk about is there are emerging trends. We spoke about robotics and autonomous systems. Connectivity. Soon enough, you will have connected vehicles. Artificial intelligence. We all spoke about generative AI or large language models this morning, correct? And electrification. Yeah? We are going to see more and more Ather vehicles on the road. We are going to see more and more Ola electric vehicles on the road, or many more, right? They are all the emerging trends. In addition to this, you have the trends in wireless communication, which is going to be 6G, which is going to be AI for wireless communication. You have multifunction radar. You have automated driving, which looks into LiDAR, LiDAR signal processing and few others. Yeah. So MathWorks collaborates with a lot of the engineering and the science education institutes to see how these trends can be addressed in curriculum. Yeah? Professional skills development is enhanced by interdisciplinary curricula. All of you, do you agree that these 4 are critical to a student? Especially the industry folks who are there, the sponsors, the guest speakers. Critical thinking. I definitely like a critical thinker. How many of you think your students have critical thinking? Okay. Teamwork. We ensure that they work in teams, but we don't allow them to work in teams in other departments. Open it up. Let them work with students from other departments. Project management. How many of you are, or how many of us, how many of our students end up doing the project on the last day? I used to do it on the last day. Yeah? And communication, how many of them know that, hey, this is how I need to write a basic agenda. This is how I need to write the conclusion chapter. Not many. Yeah? These are things that need to be inculcated, and I think a lot of this is enabled via project-based learning. Yeah? Now, this is one of the examples that we wanted to take of University of West of England, an avionics and controls lab. You see a yellow tape there or a red tape. There's a mini drone, a parrot mini drone, moving around. We incorporated a drone-based competition into their avionics course. Soon enough, this will also be run at the Indian Institute of Space Science and Technology in January semester, where the teams will end up programming this mini drone to be able to go through that path, even though there's a lot of noise around. This involves computer vision, this involves control system design, this involves coding of the mini drone using Simulink, but most importantly, the path planning is something that they learn, and unmanned aerial vehicles are the theme of today, right? Everyone likes a drone. These students learn how to program and control a drone, yeah? So this was one of the examples that we wanted to show you. The next step is collaboration. Collaboration is very, very critical, yeah? As an engineer, I had to collaborate with bioinformaticians, biologists, computer scientists as a part of my PhD because I looked at DNA and protein sequences. Similarly, I had to collaborate with doctors, radiologists, cardiologists for my postdoctoral fellowship because I was working on medical imaging. I was looking at echocardiography data. I was looking at ECG data, all of them, yeah? So collaboration is very, very critical, yeah? Now, inter-department. This is something that I cannot emphasize enough. I lost the opportunity to work at a company on a project because they wouldn't allow me to work with a computer science student. I was electronics and communication. They wouldn't allow me to partner with a computer science student for a project. Yeah? But I think it's very, very critical for you to allow your students to collaborate interdepartmentally. Yeah? Now, the main approach, and this is from the Bloom's taxonomy. Yeah? How many of you are familiar with Bloom's taxonomy here? Good. Outcome-based education is there. So we want to reinforce the concepts. Following that, they'll apply the theory where the reinforcement of concepts was done. And then there is project-based learning, which happens where they end up combining the theory and the concept. And finally, you have the multi-domain system that's done. So let's take an example of a robotics system course, yeah, which does this. And I'll tell you where this course was launched. So you have robot kinematics principles, which are very great. That's the concept. Then you have the robot controls. You see there's a robot over there and, like it's sort of a robo arm. And then we have the robo algorithm, which is over there, which is going to be, taking into account what the computer is like. There, it's a clear path jackal. Yeah. And finally, you have the robot application, which could be in a warehouse. Yeah. So this is how an entire end-to-end robotics course can start with the concept, the implementation, and then the application. Yeah? This was a course that was mobile robotics, which we have run 3 times at the Indian Institute of Science with the CPDM or CPMD, the Center for Product Manufacturing and Design. In fact, this mobile robotics course is going to be run at many, many other institutes. Yeah? We have a full-fledged 16-week curriculum for this. We are happy to share that with you. We have curriculum for many other courses, including AI for engineering. We are happy to share that with you. Yeah? MathWorks. How many of you have used help or documentation in MATLAB? Help, documentation. The MathWorks documentation is amazing. So you should be able to, pick up documentation examples. And there's also like teaching examples, which we'll be able to share. Yeah? We do have what is known as MATLAB and Simulink challenge projects. A lot of times, academicians like you come and say, hey, where can we get industry standard problem statements? Where can we get industry problem statements for the students to solve? Our customers, our industry users come and say, hey, we want to post problem statements on your website such that a student can actually pick up, and maybe if the student picks it up, we'd give them an internship or something. So you have this page called the challenge projects. This can be final year projects, master's theses, even PhD theses. There's many, many of those, something around green hydrogen production or warehouse robotic simulation, portable charging system for electric vehicles. There are 50 problem statements in fields including 5G, AI, robotics, autonomous systems, drones, renewable energy, finance, predictive maintenance, wireless communication, many, many of them. Yeah? So these are called challenge projects. Just go type MATLAB and Simulink challenge projects. You'll get a lot of these, examples. Now, one of them there is the deep learning for UAV infrastructure inspection. So UAV, the unmanned aerial vehicle or the drone is going over the road there. And then you do have the whole photorealistic simulation, the bottom facing camera. You're able to see where the LiDAR sensor is. You're able to see the low fidelity animation, the virtual LiDAR sensor, and finally the deep learning algorithm that's there on Simulink. Yeah? These are things that are going to be there in many, many places where a human cannot go and do everything. It will have to be a drone. Yeah? Now, how was this done? We created the control logic in something called Stateflow, and then we ended up using an open source framework, the YOLO model, which has the object recognition bit. We trained the YOLO model. We trained the model using YOLO v2. Yeah? Now, this is a case that's very close to my heart. In October 2018, Bosch came to NIT Calicut with us. Yeah? We said, let's talk to the MTech students who are in electrical engineering. Let's offer them project statements. Let them end up, learning electrification. We'll offer them a job after. But unfortunately, the MTech students were not very, very keen on it. So we said, why not at the fourth year, in the final year, or actually the sixth semester, not the fourth year, but in the third year, start a course called System Engineering for Electric Vehicles. Yeah? The System Engineering for Electric Vehicles had 3 components. The theory component was taught by NIT Calicut faculty. The use cases that Bosch has for electric vehicles was taught by the Bosch engineers, and MathWorks came in to show them how those use cases were simulated using SimScape. This was because Bosch came to us saying, hey, we are not able to get students. We really want people skilled in Simulink. And the Bosch, the head of the unit, then Pradeep, was on the Senate of NIT Calicut. He said, I can make things move in NIT Calicut. Yeah? So in the first year, around 30 students took the course. 24 students got placed. The very next year, 110 students took the course. They got placed in companies like Valeo, Bajaj Electric, in addition to Bosch. Yeah? Now Bosch and NIT Calicut have a full-fledged 2-year electric vehicle masters, which we support. In addition to that, we collaborate with other entities. One prominent automotive company, we are collaborating on a course on AutoSAR. Another prominent company we'll be collaborating with for a course on system engineering and IoT. So if you have your alma mater in very key positions, say someone who is a head of a unit in a company, especially automotive aerodef, ask them, hey, do you see yourself, building a course? We can pull in MathWorks or other partners. Yeah, we're happy to do that. We also have courses which will be run at IIST, Indian Institute of Space Science and Technology, at IIT Bangalore, many, many more. Yeah, so this is how the industry and academia interplays. Yeah, there are industry needs. They do not have the know-how. They do not have the manpower. You have your students. You have an edge that you are willing to change your curriculum, and MathWorks acts as a catalyst. Yeah, so do come talk to us if you'd like to, explore an option like this. As we said, academia and industry partner to make students automotive ready. So you have hybrid vehicles, model-based automotive systems engineering, multiple things from Chalmers itself. They are a pretty good institute in the Sweden area. Yeah. But also MATLAB and Simulink are not just used in academia. It is an industry standard tool. Yeah. How many of you saw the Chandrayaan landing? Watched it live. If not, it's there on YouTube. The Chandrayaan landing, the computer that's there on Chandrayaan, the computer that's shown during the live telecast, actually has MATLAB running. Yeah? So ISRO uses it. ISRO trusts MATLAB and uses it. Similarly, many, many automotive companies, many, many aero defense companies, many communication, electronic, semiconductor companies use MATLAB and Simulink. Yeah? Also, these are 2, say job postings. So this is Senior Physical Layer Design Verification Engineer. So if you notice, it sort of says experience of using MATLAB, C reference model, etc. Or for a modeling and simulation engineer, it sort of says something around MATLAB, Simulink, etc. Yep. There are student experiences, there are student competitions, which is like the design challenge that people use. Yeah. So finally, about the digitalization, I'll just take 2 minutes. There are digital skills for students. There are digital tools for teaching and learning. A lot of us were not using PowerPoint, web apps, or LMS in India until the pandemic. But now you have generative AI. Yeah. So how are we going to be able to use it? So we have a 6-prong diagram. But yes, MATLAB enables digital skills in students, multiple different areas. We do have what is called modular courseware. You can just go to GitHub and type MathWorks or teaching resources. Now, this is a 6-prong diagram. You have a digital classroom. You need to make it accessible, make the students stay engaged, industry prepared. It should be cost effective. You should look at continuous assessment and look at collaboration. Yeah. So there are many modes. So ASU, where I went to, they have an AI and IoT for first-year students. They teach both of it. It's pretty well done, and a student, is able to do that. Similarly, you have a robot which is jumping there. This is a jumping robot for a final year project in ET at Zurich. Student learn around 20 designs. Yeah. Now, there are many modes that you can do. You have MATLAB Online, virtual labs that we partner with Quanser, MATLAB Live Scripts, which is almost like MATLAB code in a Word document. And then you have the MATLAB online courses, MATLAB Grader, which is an auto-assessment platform, and project-based learning using hardware. Yeah. So there is an institute that converted a physical lab into a virtual teaching lab. A lot of us had to do that in the pandemic. Yeah. And we do have grading with MATLAB Grader. Yeah. So you do have opportunities where you can revamp your curricula. You can end up collaborating with other departments and also digitalize. Anything on this presentation or anything you'd like to talk to us, we are around. I'll be around, until the end of the session, or someone should be around. So please do reach out to us. So to conclude, there were things that we said. These were the problems or these were the considerations. We have an answer to every one of them. Yeah. So be it student competitions, we support the MATLAB Academy, project-based learning, MATLAB Grader, tools to teach or to do research, and industry. And MATLAB is an industry standard tool. Yeah. With that, I'd like to thank ICT Academy, Mr. Hari and Mr. Saravanan for the opportunity, and thanks for listening.